makers, welcome back to the Make Stuff Shed. My name is Chris, and in this video I want to show you how to control the circuits that you've built in our first two videos using a piece of software called Scratch GPIO. Let's take a look at a circuit that we're controlling using computer code. So here I've got two LEDs connected that are flip-flopping. We can't do this with just the components we have in our kit. We need something that we can program or tell to do something. Now the Raspberry Pi has been told to make these LEDs flash on and off. And when this one goes off, the other one goes on. And so it continues. We can actually make this do anything, but we're going to start off by creating something like this. So makers, in this video, I would like to show you how to program a computer to do some really cool stuff. That reminds me! Hi makers, here at Make Stuff Northeast, we're really proud of our industrial heritage. People like George Stephenson, Joseph Swan and Lord Armstrong made massive technological advances during the Industrial Revolution. And we should be really proud of that because the Northeast is a really creative place. But what you might not be aware of is that during our lifetime there is another revolution happening, the technological revolution, and the Northeast is one of the key players in that as well. There are lots of technological businesses in the Northeast that are making massive changes to the digital world. Let's go and take a look at some of the big players. Now this is Accenture, a digital business that provides technological solutions to companies around the world. Last year they announced £25 billion worth of profits. Whoa! And they have a development centre right here in North Tyneside. Now this is Sage, a global business that was formed in our region. Sage is the third biggest accounting software firm in the world, and over 6 million businesses use their software for payments. They're kind of a big deal, and it's founded in our region and based in Great North Park. Whoa! Now this is Partnership House, the home of Ubisoft Reflections. They're kind of a big deal, right? You've probably heard of them. They built games like Just Dance, Driver, Watch Dogs and Ghost Recon. But guess what? Their home is in the Northeast. Whoa! Now, we know that there are lots of large technology firms in the region, but there are also lots of really small firms that are making massive changes to technology. And right here at Campus North, they support these smaller startup firms. Okay, that's important too. That reminds me, let's get back to the shed. So makers, as you can see, the technological revolution is really strong in our region. If you can think creatively, collaborate as a team and program a computer, then you can help not only to develop yourself but also to develop our region, just like people during the Industrial Revolution did. Now what I want to do is to start your journey into computer programming in this video. Which reminds me, it's time for a Make Stuff Breakdown! So far, all of our circuits have been made by connecting jumper wires to the 5-volt and ground pins. But while you've been looking at it, you've probably noticed that there's a whole load of other pins on the Raspberry Pi. So these pins are called GPIO pins, and that stands for General Purpose Input Output. Now every single pin on the board is numbered, but they're a bit funny and not really what you'd expect. So you need to be careful when you're attaching the jumper wires to it. And that's the reason why we've given you this breakout map, so that you can attach the jumper wires to the GPIO pins correctly. And this will help you build your circuits really well. In order to make our projects today, we're going to need some stuff from our Make Stuff starter kit. So let's get those bits out right now. Our Make Stuff Raspberry Pi and breadboard combo. 3 male to female jumper wires. 2 teeny tiny resistors. And 2 LEDs. They don't have to be yellow and red. Now that we're all set up, let's build a circuit together and make stuff. Okay guys, so the first thing I'm going to do is I'm going to take one of our male to female jumper wires and I'm going to take the female end and I'm going to plug it over pin number 2 on our GPIO pins. Just like that. Now the rest is kind of very similar to what we did in the first video. I'm going to take the male end and I'm going to plug it into A1. And then I'm going to take one of my resistors and I'm going to bridge it from D1 over to G1. Exactly the same as we did before. Then I'm going to take an LED and I'm going to attach the long leg to J1 and the short leg to this ground bus. Now the next thing I'm going to do is I'm going to take another male to female jumper wire and I'm going to attach the male end to the ground bus, and then I'm going to take the female end and attach it to ground. Now what that means is I've got a circuit, but I'm going to test whether it's working correctly first, because we haven't told pin 2 to turn on. So I'm going to take this wire and I'm just going to put it over the 5 volts, and when I do that the LED lights up, so I know that this circuit is correct. I'll put it back over 2 and then we can build our next circuit. The next circuit is exactly the same, except that the female end is going to go over pin number 3, and then we're going to attach it to a completely different part of the board. So I'm going to take the male end and I'm going to attach it into row 5, and then I'm going to take a resistor and that resistor is going to go into D5 and I'm going to bridge it over to G5. And I'm going to finish off that circuit in the exact same way. I'm going to plug my LED into J5 and across to the ground. And the final thing I'm going to do is I'm going to take it out of 3. I'm going to do a little test to make sure that my LED is working. And now we're ready to do some coding. Now that we know our circuits work correctly, we can use computer code in a piece of software called Scratch on the Raspberry Pi to make our LEDs do some interesting things. Let's take a look at how we'd code that right now. Okay makers, when you start up your Raspberry Pi, you're going to get a screen that looks like this, and this is our desktop. Now the first thing that we need to do is to open up the Scratch software. So we're going to go up to the Raspberry Pi menu and we're going to click it to open up all of the applications. Now Scratch is a piece of programming software, so we're going to go into programming and we're going to go down to Scratch, and when we click on Scratch we will see the Scratch window. Now you've probably used Scratch for other things in the past, but this version of Scratch is a bit different. Not only can we control sprites on the screen, we can also control the Raspberry Pi's GPIO pins. Okay makers, I'm about to drop a bomb. The most important thing that you guys need to understand about computer science is that computers are stupid. They don't understand things. We, as humans, have to teach them stuff, and we write programs for them to run. They don't think for themselves, they only do what we tell them. So if we make a mistake, the computer will just do what it's told. If we make a mistake, we have to debug our code. And we also have to build programs that explain to the computers exactly what we want them to do. And that's what we're going to do now. We're going to create a program that makes those 2 LEDs light up. Let's have a look at it. Now, the first thing that we're going to do is we're going to use some control tiles to control what the Raspberry Pi is doing. Now, we want our programs to start when the green flag is clicked. Okay, but because computers are stupid, the Raspberry Pi doesn't know that we need to have the GPIO pins attached. So what we're going to do is we're going to put a broadcast in here, and we're going to put in there a new broadcast of GPIO server on, and then we're going to put that in. Now, broadcasting GPIO server on tells the Raspberry Pi that we want to use the GPIO pins. Now remember that we attached 2 LEDs to GPIO pins 2 and 3. And we're going to tell the Raspberry Pi now that we want to use pins 2 and 3 to control our circuits. Let's go back to the code. So we're going to use another 2 broadcast tiles. Now what we're going to do is we're going to put a new one in here, and what we're going to do is we're going to configure GPIO pin 2 as an output. Okay, so config 2 out means we're putting pin 2 as an output. And we're going to do the exact same thing for pin number 3. We're going to config 3 as an output. So, now we've told the Raspberry Pi to use the GPIO pins, and we've been really specific and told it that we want to control pins 2 and 3. And remember that we've got our LEDs attached to pins 2 and 3. Now that we've done all that, we can do some funky stuff with the code and make the LEDs light up. Let's take a look at how we do that, makers. In essence, makers, what we're going to do is we're going to turn these LEDs on and off. So I'm going to put in here a broadcast of GPIO2 on. And then I'm going to put in another broadcast of GPIO2 off. And then I'm just going to put a little wait in between those, and I'm going to make those 4 tiles happen forever. Let's have a look at what's going on here. We can see that the LED is flashing on for 1 second and off for 1 second. Now this is the LED that's attached to pin number 2. And why is it doing this? Because we told it to. We've told it to be on for 1 second and off for 1 second, and to do it over and over and over and over again. This computer is stupid, but it's doing exactly what we told it to. But could we make it do some other stuff? If we want the LED to flash faster, all we do is we change the wait times to a smaller value. So I'm going from 1 to 0.2, and that will make the LED flash a lot more quickly. Also, if I only wanted it to flash a certain number of times rather than forever, I can swap my forever loop out and replace it with a repeat loop. And what that means is, rather than going on forever, it'll only flash 5 times. Now makers, I bet you're sitting there thinking, why did we bother attaching the second LED to pin 3? Because he hasn't shown us how to do that yet. Well, now we're going to do the flip-flop. So let's take a look at the programming. Okay guys, this is really easy. We're going to work smart rather than hard. So what we're going to do is we're going to duplicate all of these GPIO2 lines of code, and we're going to change it from GPIO2 to GPIO3. I'm not asking you to copy it out again. I'm just asking you to edit it so that it works correctly. And now this code will make number 2 light up, go off, number 3 light up, go off, and do that over and over again, so we get the flip-flop we were talking about earlier on. Okay makers, if you can make 2 LEDs flip-flop like that, you can start to create code and build circuits for anything that you like. Let's think about the skills that we learned in the first video and what we just learned and create something awesome. Remember, the main thing about this project is that we want you to get creative and make stuff. You can add more LEDs and create whatever light show you want. Let's have a play around with it. Do you remember this project from our first video? Now back then, the LEDs could only all be on and all be off at the same time. But because we're now controlling all of these LEDs using computer code, we can create any light sequence that we want. Now I think that is pretty cool! Well makers, that's it for this video. We've looked at the other GPIO pins on our Raspberry Pi. We built some circuits connected to those GPIO pins. We attached some LEDs to those circuits, and then we used computer code in Scratch to control those LEDs. I think that we've done some great stuff today, but we really need you to go away and play and develop your own ideas. So until the next time you head to the shed, get out there and make stuff.